بس ينقل لك المايك. بندعم هذا ما تحتاج هذا.
Steve. Last chance for WorldFAIR Plus. Okay. Right. Okay, welcome everybody. Thanks for choosing this session. We recognize that there's a lot of other sessions going on. There's the affiliated bodies continuing. There's the group of Latin American members is also meeting at this time. So thank you very much for coming and choosing this session and coming to hear more about CoData and about WorldFAIR Plus. So that's what we're going to be talking about mostly. There's a leaflet on CoData as such. Please look at that, but we're going to be focusing on the WorldFAIR Plus initiative. Subtitled Making Data Work for Cross-Domain Grand Challenges. And hopefully already you have an idea of what we're concerned with then. Two quick pieces of publicity before I get into the presentation as such. CoData with two other international data organizations, the World Data System and the Research Data Alliance, and with our Australian hosts. The Australian Research Data Commons is organising International Data Week in Brisbane later this year in October. There's a URL and a QR code there. It's a big meeting of people that care about data in various ways, data policy, technical issues around data. It's a good place to meet that community. And as part of that, that conference in fact combines two conferences. It's a hybrid in the old sense of the word, though it will be hybrid in the modern sense as well. So it combines the Research Data Alliance's plenary meeting as well as SciDataCon, which is organised by CoData and the World Data System. The call for sessions and for papers for SciDataCon is open at the moment, QR code and a bit.ly as well. Okay, so today we've probably got about 90 minutes now, haven't we? So we'll try and rattle through. We've got 100 minutes, 95 minutes if we're going to finish on time. I will give an overview presentation of WorldFAIR Plus. We'll have some time for discussions and a guiding question there. What are the interdisciplinary challenges in your related to your discipline or in your country? And then we'll have some short presentations from case studies associated with WorldFAIR and WorldFAIR Plus, and one of the new projects going forward. And then hopefully we'll close with some discussion about how to get involved. The reason why we're doing this with ISC members and partners is that we want to identify organizations that we can work with that have a strategically important interdisciplinary project or set of projects where we can collaborate and we can bring to the table some of the advances that we've made in data integration, and also that we can learn from what you're doing. So very much a partnership approach. So that's the agenda, and now I'll launch into describing what WorldFAIR Plus is. Two slides that I was advised to put in, just to make sure everyone's got is everyone familiar with the FAIR principles? I think. This idea that the data should be findable, accessible, interoperable, and reusable. Those are the high-level principles, and there's a set of sub-principles which provide a little bit more guidance on what that actually means in practice and what you need to do to meet those principles. They were published in 2016 in an article in Nature Scientific Data, which has had considerable influence in terms of citations, but also in terms of its influence on the data community and other areas of science, and the adoption of the FAIR principles and steps to try and implement them. As well as those high-level principles, they emphasize machine actionability, and we need to discuss perhaps precisely what that means. And they're also very much endorsed by funders, including the European Commission, because of a perception that this will advance research, it will enable discovery. It will make research more efficient. And some of the evidence for that comes from a report by PwC, which estimated the opportunity cost of not having FAIR data, so not having data that's easy to find, easy to combine, easy to use, of being at least 8.2 billion euros, so in the European research area, so significant. CoData has been very much involved with this. Our current president, Messi, who hopefully many of you have met this week, is one of the authors of the paper, as was our previous president, Baron Mons, who hosted the workshop that led to the original paper. And I chaired the European Commission's expert group, which produced a report called Turning FAIR into Reality, which described how to implement the FAIR principles in the European research area. So now on to making data work for global grand challenges, or cross-domain grand challenges, and WorldFAIR Plus. There's some background to this. CoData, as the Committee on Data of the International Science Council, we're not just a committee, we're an affiliated body. We have our own legal status, our own funding, but we exist to serve the mission of the International Science Council. At the point of the union of ICSU and ISSC, we were asked, as part of the action plan that was developed then, to develop a program of activity called Making Data Work for Cross-Domain Grand Challenges. The reason for that was that ISC, as it now is, ICSU as it then was, sponsors a number of interdisciplinary research programs. IRDR, Future Earth, Urban Health, etc., which are fundamentally interdisciplinary. In fact, the major global challenges that we face, climate change, mitigation, adaptation, disaster risk reduction, the growth of cities, the loss of biodiversity, are all, in one way or another, fundamentally interdisciplinary. And to address them, we need good science, and for the good science, we need the good data, and often that means combining data from many different sources and across domains. So our task as CoData is to identify the policy recommendations and the technical solutions to assist and support that. So we started work in that area through a number of small projects, a series of workshops, and then we got some funding from the European Commission for the WorldFAIR project. I'll say a little bit more about that, but that was fantastic because it was a large project and we were allowed by the Commission to have partners from all over the world, and to have beneficiaries from all over the world. This is very rare, and in an age of increasing geopolitical tensions, this will be even more rare. But we were able to run that project for 2 years and to have partners around the world. And now, post that project, we have a set of products, a set of recommendations, both policy and technical, that we're going forward with in the context of WorldFAIR Plus. So that's the narrative. And having spoken to that, I realize I can skip over some of the next slides, which explain that in more detail. So this says a little bit about the origin of that work, making data work for cross-domain grand challenges, and the premise and the idea that we would work with ISC members, interdisciplinary bodies, affiliated bodies, etc. This explains about the WorldFAIR project and the funding from the EC, and really a very ambitious project with a whole load of partners from around the world, including partners in Kenya, in Brazil, in New Zealand, in Australia, in the US. I said Brazil, didn't I? And in various countries in Europe as well. But very much with a global scope, because we had as important partners authoritative international entities. So IUPAC, as an ISC member, as a legal entity in the US and in Geneva, some complications there, was a partner and had an opportunity, as you'll hear from Richard later, had an opportunity to work on how to make IUPAC assets fair. We also partnered closely with GBIF, the Global Biodiversity Information Facility. Through colleagues in ocean sciences, we partnered with UNESCO IOC and the ODIS initiative, the Ocean Data Information System. And we made sure all through the project that we had strong connections with international data standards bodies and UN agencies that implement those standards. So that's an important part of the approach, to try and develop standards that work across domains to address those global grand challenges, as I said. So this is that's the sort of organizational part. This is the interesting bit, I think. The 11 WorldFAIR case studies. We were incredibly ambitious. This was way too many case studies. We had to work ourselves into the ground to engage with all the case studies and projects involved. Our vision was to bring together a number of case studies to understand in detail their data so that we could make recommendations about how to make those data more fair and how to integrate those data more effectively for research projects. The color coding indicates a degree of clustering. So we had chemistry represented by IUPAC, nanomaterials represented by a number of research groups in Europe, geochemistry represented by an Australian organization, OSCOPE, but really as a vehicle for an initiative called One Geochemistry, which is a global initiative that involves a number of geochemistry data centers, as well as international scientific unions. Social surveys, which was led by Steve, and we'll hear that about that later, and was a collaboration between the Australian Data Archive and the European Social Survey. Population health, which was engaging with a large project in East Africa, led by the African Population and Health Research Centre, and of which we're still a partner as that goes forward, looking at integrating population-level health data with clinical outcomes data and moving towards an exposome approach to health studies and data sharing. Urban health, which was based right out of Drexel in Philadelphia, but as the grant holder for a project called Salud, Urban Health in Latin America, and drawing on their experiences with integrating urban health data. Biodiversity led by GBIF, agricultural biodiversity led by Embrapa in Brazil, looking at pollination data and how we make that more available. Ocean science is led by the Alfred Wegener Institute, but really for the connection with ODIS. Disaster risk reduction, led by involving a number of partners and led by Tonkin and Taylor in New Zealand. And cultural heritage, again involving a number of partners, but led by the Irish digital repository of Ireland. I knew I'd got that the wrong way around. So, incredibly ambitious. But that's our mission as CoData, to work across all domains and to really understand how the data works, how the metadata works, and how we can help each of those disciplines and interdisciplinary research areas combine their data more effectively. That was the task of this work package 2, this synthesis work package. So, 2 main outputs. There were many outputs from each of those case studies. There were a set of reports and recommendations. But what I'm going to talk about here more is 2 of the main outputs, a policy recommendation, which I'll come on to, and a thing called the cross-domain interoperability framework. Our purpose with the cross-domain interoperability framework is to identify the functional requirements for integrating data, for research, for models, for analysis in interdisciplinary research areas, and how we make that easier. This happens a lot. These interdisciplinary projects exist, but often the data integration involves a lot of manual wrangling and detailed work. It's incredibly time-consuming, and it often can't be repeated, and sometimes the reproducibility of it is questionable. We're trying to propose an approach which uses standards, which uses a set of recommendations to achieve a number of purposes. To make it more efficient, to make it more traceable and reproducible, and to make it repeatable, so that year on year with time series, you can start automating that data integration process. That's our purpose. So, working with those case studies, we identified a set of functional requirements, and then we made a set of recommendations, preliminary recommendations for how the data integration can be improved. I always like showing this cartoon from XKCD. This happens all the time. There's a load of data standards or standards of various sorts. We'll propose one that unifies them, and now we just have another standard. This is not the trap. We are convinced this is not the trap that we've fallen into. We've identified the functional requirements, and then we have pointed to existing standards which can help, with certain implementation guidelines, address those functional requirements. So it's a framework of standards rather than a proposal for a new standard, and that's really important. So we learned from the use cases, and the report that came out of it, and it's now on the web as a CDIF book, is a guide for implementers. So there's explanations of what's involved, why the functional requirement is important, and then a whole lot of code to help the implementers implement it, to do their jobs. And I'll talk a little bit more about that now. So, a set of practical implementation level principles designed to improve data management practice within a community and lower the barriers to cross-domain data sharing and integration. We identified for the first version these 5 areas. Discovery, a set of recommendations on how to improve the discoverability of your data. Data access, using the Open Digital Rights language to encode the access requirements and to make, as a step towards making that more automatable. Controlled vocabularies. Always with data integration, we need to think about semantic interoperability. Are the concepts that underpin the phenomenon, or that describe rather the phenomenon that has been observed in 2 different data sets, are those concepts the same? Are they described in the same way? In essence, are those data sets commensurable? If they've been described in a slightly different way, and Steve will talk a little bit about this later, can we find a mapping that allows us to integrate those data? This is fundamental to interoperability, to the reuse of data, to combining data from different sources. And we make recommendations about encoding using SCOS for that. Core data description. Here it gets really interesting. When you combine data sets, you need to know about the data structure, you need to know how the variable has been defined, you need to have some information about the processing that that data might have undergone. The DDI-CDI standard provides that information, and so we recommend that. And then universals, often data sets are linked using time and place and a number of shared concepts. And so there's a discussion of how to use that. Now, so I've launched into a relatively technical discussion of this, but I hope that in the way I'm talking about it, you can, I don't know how many technical people there are in the room, but all these concepts should be familiar to us all as scientists. And hopefully you can understand how these recommendations can be useful when it comes to putting data sets together. Now, we published this at the end of May, at the end of the project, in 2025. We've already had a significant degree of adoption and some very good feedback. We got this email over the summer, and we were absolutely delighted. This comes from someone working in a physical sciences data infrastructure who looked at the report, and I loved it because it was so, we were very pleased with the feedback, obviously, but it was so honest. The person had downloaded our report and wasn't too excited to start reading it because it's a very long one. It's 150 pages. It's 150 pages because there's lots of examples and lots of code, so it's not that off-putting. But the feedback was fantastic. It was, is it your job to work out the design of metadata for a cross-domain repository, and would you like us to tell you how you might do it in the best, most fair way? So, the feedback we got is great, and that has led to a set of new projects which I'll go and talk about. So, why am I showing this? To show that at least, this is only one data point, but we've had other feedback of the same sort. It does seem to be striking a chord with data centers, with data repositories, and with projects that are having to work in this space. And so the next steps. And now I'm going to talk about the next steps for CDIF, for the Cross-Domain Interoperability Framework, and for WorldFAIR Plus as such. So obviously those functional requirements that I mentioned discoverability, how we deal with vocabularies and terminologies, how we integrate data, how we deal with access requirements, how we link data using universals. That's only a small part of the story. And the recommendations that we made are preliminary as well. Certainly for access, a lot more work needs to be done. For integration, a lot more work needs to be done. For description of variables, for description of terminologies, and for mapping across terminologies, more work needs to be done. But we know where to go, and we think with the experience of WorldFAIR, we have some good ideas of the partnerships and the standards that are available to do that. So the green ones are where are the new areas of work. More work on access, descriptions, more work on mappings and data description for integration, and then some really important and challenging areas of work which are of scientific value as well. How do we describe the context in which data has been created? How do we describe the provenance and any processing that may have happened? This is really important for reproducibility, to help scientists who want to gather data from a number of different sources but want to know about the quality of the data. So quality comes under this as well. And it's increasingly important in this AI world where the training sets that go into the AI need to be of high quality and also need to have a lot of provenance information so that the AI has the maximum information about the data to incorporate that into the foundation model. So that's our agenda next, and that's the work that we'll be doing. And we'll be doing that in the context of an international working group with an advisory group, but also in the context of a set of new projects. So WorldFAIR, the project, so that narrative that I showed at the beginning, the initiative that ISC asked us to do turned into WorldFAIR and is now turning into WorldFAIR Plus, because we lack imagination, we like the WorldFAIR logo and we like the branding. But WorldFAIR Plus isn't a single project. We keep having to explain this because people are used to us talking about WorldFAIR as a project. This is not a single project, it's a federation of projects under one umbrella and learning from each other. CoData as an international organization will do the maximum we can to ensure all these projects learn from each other and do so by implementing, testing, refining and further extending the cross-domain interoperability framework. So I've got 3 or 4 slides of a lot of text listing these projects. The slides will be shared. I'll try and go through them quickly, but the purpose of this is to, A, convince you that this is going forward, the work is going forward, and B, to demonstrate to you the range of research areas and to indicate the type of interdisciplinary project and research area that we're interested in. So I hope in describing these as briefly as I can, I will give you some indication of the sort of collaboration that we're looking for. So the first one is a continuation of Work Package 7 in the original WorldFAIR on population health. So our partner, APHRC, have a new project with welcome funding on data sharing, following that exposome approach, again, looking at population health data, statistical data, clinical outcome data, phylogenetic data, environmental data, but sharing across 4 African health research centers in Nairobi, in Addis, in Dakar, and somewhere in Cameroon that I can never remember. Really fascinating project, a lot of learning about the technical requirements, and a project of considerable importance as well. Fair data and emergencies. This is a small grant from ISC to help us with this because we've done a lot of work in relation to ISC's activities on disaster risk reduction. 2 case studies, one with partners in Ankara on the Turkish earthquake and developing a national disaster data platform, and another looking at issues around the Malawi floods and then cholera, which is a cascading hazard, which is always of interest to people that work in that place, in that space. CDIF4 XAS data, so X-ray absorption spectroscopy data. How do we describe that data that comes off many beamlines around the world and has a whole load of different formats and standards? How do we describe that data in a way that it's more shareable even within that domain? But above all, X-ray absorption spectroscopy data is used outside that domain. So the CDIF description enables that cross-disciplinary use. Climate Adapt for EOSC is a large Horizon Europe funded project looking at climate adaptation with 3 fantastic interdisciplinary use cases. One on urban heat, one on coastal land management and erosion, so combining ocean data and land data and property data. Another one on clay soils and buildings. Drought, clay soils shrink, buildings collapse, so you need the soils data, you need the environment data, precipitation data, you need the built environment data, you need the insurance data. Again, fascinating research area and right for the sort of work that we're doing. FAIR Principles for DDE, this is an international program on geology and how do we implement the FAIR principles in that context. So those are the 5 that are already underway. We received good news recently about JustSafe, which is another Horizon Europe project, closely aligned with Climate Adapt, slightly more on the policy side, but with also a strong citizen science dimension. So that's going to be really exciting to bring that data in as well. Shiley will talk to you later about one of the shortlisted projects for the ISC science missions on urban heat islands, and again, interdisciplinary and transdisciplinary using data from a whole multitude of sources, the environment data, the climate data, but also in situ data and data from interviews and assemblies with the citizens involved, and it's led by a woman-led NGO that works across Indian cities called the Mahala Housing Trust. And finally, we're in discussion with the Australian Research Data Commons to prepare a program for the next few years for earth and environmental sciences as well. So, a lot of work. This gives a little bit more information about our discussions with ARDC, so the Australian Research Data Commons. They picked up CDIF and the policy recommendations that we made and incorporated that into a white paper, which says essentially the work that came out of WorldFAIR is really important. CDIF provides some solutions and needs to be tested on the ground, and we recommend doing that in the next program as a way of uplifting the FAIR principles, but also to help us address the CARE principles. CARE principles, very briefly, are principles for indigenous data governance. Those decisions about governance are made by the indigenous people themselves, but by encoding those decisions, using the CDIF recommendations, we can make them more easy to implement and to respect. And that's the message of that paper, which is linked there. So, I don't know how much time I took there, probably plenty. But I hope we might have 10 minutes for any questions and discussion before we hand over to the other speakers. Please introduce yourself and ask your question.
So Marius Policarpo, I'm with the Cyprus. Marius Policarpo, I'm with the Cyprus Academy of Science, Letters and Arts, and I'm also working in the AI area and automation, so I'm quite familiar with what you were talking. So one of the things I wanted to see, I mean, you talked mostly about European projects. I was wondering if there's anything with other countries funding as well and so on. And my second question is whether we could have access to your presentation.
Yeah, so of course that's a given. If I fail to introduce myself, I'm sorry. I'm Simon Hodgson, an Executive Director of CoData. I thought that was on the opening slide, but if it wasn't, then I'm sorry. We've had various funding sources for this. It's a challenge. CoData is an international organization. We're a membership organization. We have some membership funds that we use for these sort of activities, of course, but we're reliant on expanding our activity. To expand our activity, we're reliant on funding. Because we're a French NGO, we're eligible for European funding, so that gives us an advantage there. But not all of this funding is European, or is being spent in Europe. The funding from the Wellcome Trust goes to the APHRC, and then we work as a technical team for them. So that we're sort of funded in turn by the APHRC for our technical advice. The ISC funding comes ultimately from the Taiwanese Academy of Sciences and their initiative on disaster risk reduction, and is used by us in Malawi and in Turkey. Obviously, we use some of that for our technical experts, but the next two, CDIF for XAS and the Climate Adapt, yes, they are European focused, but with broader, the funding is European, but there are broader implications. Each of those research areas, those case studies, is of relevance to other geographies, and our task as co-data is to make that clear, is to communicate that to our partners around the world. And XAS, we've already got a number of beamlines around the world involved in those discussions, even though it's European funding. And then finally, the FAIR principles for DDE, this is global, and the funding comes from IUGS. So, yeah, please. So we're acting like influencers and speaking like this.
Thank you. I'm Professor Saman Sinavira. Actually, I'm from Sri Lanka. I'm a president of the National Science Foundation of Sri Lanka, and my background is by training of agriculture scientist and big data and climate space. And especially, I'm coming from my career in Australia, and but very recently moved to Sri Lanka, in the aiming to help the agriculture sector. So what we have identified is a data issue. The big data, and our productivity is much lower than when compared to the rest of the world, and which we have not capitalized the data. There is a great opportunity, especially in the agriculture. Both the agriculture I always define as optimization of biology and environment.
Yeah.
So environment we have not properly optimized because we don't have data. Like together. And we have great opportunity to even go for a big funding application because it's a country priority, and we also can be a co-fund of the program, and maybe there is a lot of opportunities in a European support.
Right.
So this is what can you be a player in this application, and especially for the international application and building the whatever the data required. And also taking this data into the large scale modeling and to get the whole system up and running. And my second thing is the other advantage being in Sri Lanka, we have hundreds of microclimate patches. Nowhere else in the world that have. We can learn a lot and we can adapt this thing for the rest of the world.
Yeah.
And top of that one, we have other issue, is a nutritional issue because of all the climate change, and together all the cereals have been being affected, and nutritionally they have been depleted. So there's another question, two questions together address food security and nutrition security. I think you can capture the whole lot of information in a very high resolution manner. I think we have a really big team together.
Yeah.
Thank you.
Fantastic. Thank you. That's exactly the sort of idea that we hope to tease out in this session. What we're looking for now, we have some products, if you like, from the WorldFAIR project. The CDIF, the experience we developed, the how to work with teams to understand what needs to happen to data to make it fair, what needs to be done to implement the CDIF, and how that can help with the data integration for interdisciplinary research areas. Our mission now is to identify exciting, high-priority interdisciplinary projects where we can work with partners to test those ideas, to improve them, to learn from you and your research areas, your research priorities, but also the sort of data that you have that we won't have addressed yet. So it's exactly that sort of partnership. So if we can have an online meeting and understand the sort of research projects that you're interested in and how the CDIF policy and technical recommendations can help, then that's the sort of collaboration we want.
Fantastic. Thank you.
Any other questions?
Present my so glad to be here, and I'm Hakan Arar from Turkish Bilim Akademisi, which is a NGO standard non-governmental science academy in Turkey, and we are dealing a lot of multidisciplinary and transdisciplinary type of works, especially with the resilience for the earthquakes. We are pretty much open to all kind of collaborations in that matter. We have a good access of experts and other individuals that are pretty much active in this area, which is also very active in Turkish setting because of the geographical location and also the last earthquakes that we had. On the other hand, I'm trained as a physician, but I'm doing also some public health type of work, and we are in my university partner of a big European project, I think, which is a very interdisciplinary, which is the RMAP. This is the mapping the remote work conditions in urban and rural Europe in general. And I think we had to deal a lot of disparate data, and the data curation is absolutely a nightmare for such kind of work because the all those standards and other things that you just mentioned doesn't exist for most of the part. Yeah, I'm also eager to go any kind of collaboration.
Yeah, fantastic. Yeah, RMAP has been mentioned to me before, and I need to sort of look that up. But yes, I'm aware of some of that work, and I think we have some collaborators who are involved. Yeah.
Simon, thank you very much. It's been great progress since we have met in 2019 or so. So I'm glad that you have achieved such great achievements. Let's give you an idea about the landscape here in Oman. We have like different universities and the landscape in higher education, and it's of course the research is embedded into the universities. However, we also have like a number of multidisciplinary research centers. Even it's like dedicated for domain, but the research centers are actually inter and multidisciplinary. Similar to what you have actually displayed. I'm talking about the local context now. We have also here in Oman have developed such a network to connect all the data locally, and also now we are going beyond to the region, the GCC. We are going actually beyond Oman to the GCC region, which is Gulf Cooperation countries, and also we have received a number of requests related to the data combined with the research. So now wondering, yet we don't have like a single centralized unit. However, we have like a number of research centers. Those also, all of them are working within the multidisciplinary and interdisciplinary. Just wondering the question, how we can actually connect all of these things within your network that you have developed.
Yeah. I mean, I think my recommendation for how we can best engage is again to identify a high priority research question or topic that would be interdisciplinary, to meet with a research group that combines that interdisciplinary research and to understand what data they're using, what data they need to combine and integrate, and then for us to be part of a project that would be a research project, a research activity, but we would be providing input on the data stewardship. how to describe the data, and really, our mantra at the moment is implement, test, refine, and extend. So for the CDIS, so that means testing it out, giving us feedback, helping us improve it, the recommendations, and hopefully we seeing the benefits of it when the data is integrated, particularly with time series data, and then can be integrated year on year. So it's that. It would be a partnership, and it would be an interesting research area like one of these, but one which is of importance to the partner organization, because it's high priority, but where we would see a scientific benefit from the sort of data integration recommendations that we provide. Okay, great. Diana. I think you have to hold this. You have to hold this bit.
Now?
Yeah.
Yes, okay. So, yeah, thank you very much for the presentation. So maybe one of the challenges I was thinking related to my own expertise has to do with the languages of the different data. No? When you share data, this data is related to different languages, sometimes different alphabets. So this is a challenge when you need to share this data and to understand what this metadata means, no? So, and in a similar way, maybe when you deal with historical data, many archives, they are scattered around the world, or data that is non-existing. So when this data is missing because it's related to women, for example, because they were not considered important, and so what do you do with this? No, how do we fill these gaps?
Yeah.
So I don't know if you have reflect around these issues, or when the data is not well structured, because for many disciplines this is the case, and it's our daily basis.
Yeah. There's a number of issues there. Some of them are easier to address than others. The language issue, I'm not going to be blasé in saying it's easy to address, but it's a matter of conceptual mapping, ultimately. So from a data perspective, whether, in different data sets you might have a slightly different definition of the variable, the thing that's been observed or measured or whatever, and it might have been described in a different language. That remains essentially from a technical perspective the same challenge. So we need a mapping. So that's, that can be done. I'm not saying it's easy. I'm not saying there isn't blurriness or fuzziness in those conceptual mappings, but at least there's an approach. In terms of the absence of data and how we deal with unstructured data from non-traditional, non-established or sort of digital sources, again, that's a real challenge. It's really important that we address that. And that's an area that we're moving into with this work, with some of the work with the health project, with the citizen science related work, and with the work that we'll be doing with Shiley. So we don't have immediate answers to that. We're aware that it's an issue. It needs to be, for those data to be present in the analysis, they need to be encoded in one way or another. There are techniques for encoding qualitative data, as you're aware. We need to start implementing that and making recommendations about that as part of CDIF. I think that's all I can say there. I should have mentioned, actually, there's a lot of linguistic and in Data Science Without Borders, a lot of the terminologies there are in different African languages. A lot of them are folksonomies for the particular particular illnesses. Forgetting the technical term, but the things going wrong with people. We're having to map their established terminologies against equivalent terminologies in local languages, against folksonomies. And that's a technical challenge, but it's a really important one to address and to include those data. I think Steve wanted to say something about that. So thank you very much for those questions. I think in the interest of time, I'm going to have to hand over to my other speakers who will give quick introductions to the work that they did as part of WorldFAIR and how they want to take that forward.
Right. My name is Richard Hartshorn. I'm from New Zealand. I'm a professor of chemistry at the University of Canterbury in Christchurch, Simon. I have done a significant amount of work with the International Union of Pure and Applied Chemistry. I was its Secretary General for 8 years, and I am currently Vice President of CoData. I got involved with CoData because IUPAC could see the benefit of being fully engaged with CoData. We had projects and we wanted to be engaged at a governance level as well. And that level has actually been really borne out, or the importance of that has been borne out through things like the WorldFAIR project. What we're going to talk about is how, as you all know and will fully understand, chemistry is the central science. What we mean by that is the chemistry and chemicals are used throughout a whole bunch of different disciplines. And if you are going to organize your science, whatever it may be, and it does involve interactions with chemistry and chemicals, then you will need to take into account the issues around chemicals, the chemical data, and the things that are tied to that, the ways that they are characterized. So not only are we talking about how chemists can talk better with each other, but we're also, more importantly perhaps in the context of WorldFAIR, talking about how the things that chemists can do can be made more useful to people in other disciplines. And I will be showing you a couple of case studies from things that are on this slide. So you can see that this slide's organized by the FAIR principles. We've got things that are related to finding information about compounds. We've got things that are related to actually getting hold of that data and being able to use it for things. And then issues around interoperability. You need to know how that data is structured in order to be able to use it for useful things. And then finally, the reusability. One of the big issues there is how reliable is the data, what sorts of things you got there, and then we get into areas around validation of the data and the sorts of things that are important in that way. And I hope you can perhaps imagine that whatever your discipline may be, although possibly some of the people-related things may struggle a bit more, whatever your discipline may be, some of these things may be more useful. And so you will see that I will talk about some of the standards on the right there, which are particular issues around how we describe spectroscopic data, the data that characterizes compounds, and then how we can access it and make use of it. So, for example, and I've chosen one here because it's one that actually will be really useful across multiple disciplines. So IUPAC has, some time ago now, actually, more than 20 years ago, started the production, and we're still implementing more aspects of it, of the International Chemical Identifier. So this is a character string that describes a chemical structure, and that string will be common for every time you produce that structure or draw that structure, you can produce the INCHI string. And if you store your data, if it's related at all to a chemical, for example, if you're using a fertilizer in an agricultural application, you might link data together by what the fertilizer was and what its INCHI is, and that will allow you to then access all the kinds of data that might be related to those studies. So we have the full INCHI, which in this case is for that molecule shown there. I'm not going to get into the chemistry. I could test you later about that, of course. Being a professor, I would want to do that because testing's important, right? But the INCHI is structured so it tells things about chemical formula, the connectivity. In this case, the molecule is optically active. It has different isomers and so on. Because molecules have different sizes, that means the INCHI string will have different lengths. And that can make it difficult in terms of practical IT technology, in terms of searching. And so we have a hashed version of the INCHI, which is a standard length hash where you convert the INCHI into a standard length code. And that then is known as the INCHI key. And that is a really useful string for searching. The length of the string is determined by what Google likes and things like that. But the fact that it's all the same length means that you can use that in a very powerful way to search through all kinds of different data sources. So the INCHI is a really important standard in terms of taking chemistry out to other disciplines, because you can use the INCHI to connect your data using the chemical aspect of your project to other projects that may not be at all in your discipline, but which use the same compound and so on. And what this means is that we are looking at the applications where you can use the INCHI key, and another character string that represents structures of SMILE strings. They're much more, there's some problems, issues with SMILE strings, but they are widely used. We've got this, as we know what we've got for a molecule. We've got databases which contain that, and then we want to get hold of the chemical structure data, or the things that are tied to the applications of that molecule. One of the challenges we've got is that many of the databases in the middle there, they are accessed in different ways. Now, if you're a human and you want to access, you can look at the databases, follow the instructions, and work out what you have to, how you have to put your input in to get the data out. Okay. What we're looking at is a global resolver, which is essentially a tool which automates the process and can be done in done at scale, so that a large amount of data or large numbers of molecules can be studied in this way, and you can access different databases. So essentially it provides an overarching interface to manage that process, so you don't have to look at your database, work out what it is, how it works, and so on. We're hoping to produce some kind of overarching standard and approach that will provide a mechanism by which we can do that kind of thing. So that's the global resolver, which involves making the INCHI and the INCHI key much more useful, because we're looking at databases that have got that information in them, but which you need to be able to access and deal with properly. In chemistry, the crystallographers are the stars, actually. Here's a molecule that we made in my research group. It's rather pretty, beautiful purple color. This is the kind of result you'll see in chemical papers. It shows you the detailed molecular structure of the molecule. And you can represent molecules and draw them in different ways, and that can create problems. But the crystallographers have done a wonderful job. So the International Union of Crystallography has done a wonderful job with the CIF standard, the Crystal Information File Standard. This is a standard file structure that includes all the data that's related to that chemical structure. And so this happens to be an extract. It's a much bigger file than this, an extract from the CIF file for the molecule I just showed you. Okay, so this is a really useful tool. More importantly, actually, they have also produced a validation software suite called CheckCIF, which uses the CIF file and interrogates or checks on aspects of the CIF file to identify potential problems, challenges, or unusual features of a particular crystallographic study. And so that's been proven to be incredibly useful in refereeing of journal articles and so forth, but it also helps scientists make sure that they're doing a good job. Okay, so this is a really good example of how you can produce a standard that's widely used. All the chemical publishers require the CIF file submission related to crystal structures, and the CheckCIF validation suite that makes things actually useful. But related to that, of course, I alluded to the fact you can draw structures in different ways. And one of the things we want to be able to understand is whether the structure that you might draw is the same as the one that you might draw. Okay? Now we can use things like the INCHI. We could take your structure, convert it to an INCHI, take yours, compare the two, and do things like that. But we also want to consider how you might do that sort of thing in a machine actionable way, which involves being able to read and understand chemical structures. And so what we need to do is we need to have a way to check that the different ways that software interprets these structures are the same. So the ways that things are dealt with may differ, and the way we check on that is to use things like the INCHI and so on to check whether the structure is the same. But we also want to use it as a tool to improve the drawing of structures. So we can check on the structures that people might draw and interrogate questions, find potential problems with the structures to see if there's an error in the drawing. Because if you have an error in the drawing that goes into the literature, then you end up with the literature being contaminated with molecules that never really existed because it's actually just a technical error, okay? And so the correct valences, for those of you who don't have any chemistry, it's about how many atoms are bonded together. We have things called implicit hydrogens, which are really problematic because that's where drawing software adds in hydrogens without being told to, and similar kinds of things. And then stereochemistry, the configuration of stereocenters, different isomers, is a real problem because that can be quite difficult to represent in an appropriate or unambiguous way. And so these are things that can be checked for a particular structure. And so what we're looking at is tools like the global resolver and the structure validator as ways to enhance the availability of chemistry and chemical concepts to disciplines outside of chemistry. And so this is how chemistry is going to continue working in the WorldFAIR Plus program as we start to elaborate on some of these things that we're doing as part of this work. So there's the global resolver. The FAIR Chemistry Cookbook is tied to a whole bunch of ways that you can present your data in a fair fashion. We've got the Gold Book, which is an online resource that provides definitions and so forth, and terminologically useful stuff related to chemistry. And then down at the bottom there, a friend to me in particular, because I'm involved in it, the DRUM, so digital representations of units of measure, because it turns out that units are really important in most sciences. And in actual fact, the digital application is particularly significant in chemistry as well. And so there are actually chemists involved in and leading the DRUM task group as part of CODATA. So there's a whole lot of work that's being done in terms of WorldFAIR that is really useful there. So if you want to find out a little bit more about this, those QR codes will take you to some reports that are talking about the progress that's been made on the FAIR Chemistry Data Guidance, the cookbook, and on other services that we're looking to do in the chemical domain. Here are my acknowledgements. The chemical structure I showed you. Dr. Rajika Munasiga was a student in my group, so she's from Sri Lanka actually. Fantastic student, and it was a beautiful structure, and she did some brilliant work. The Inchi Trust is doing a lot of work in this area, has done for a long time. Leah McEwen was the leader of the chemistry WorldFAIR package, and is totally awesome. She's the chemistry librarian at Cornell University, and also a legion of volunteers because IUPAC has a couple of thousand chemists who donate their time gratis to work on issues related to that. And finally, down the bottom, there are a number of the organizations that are involved in chemical data standards and similar work. Many of them are based in Europe, but they are doing different aspects of much the same sort of global picture, and we're seeing that this sort of work where we're trying to build the ways that you can make chemistry more useful is something that they're right involved in as well. So that's me done and dusted. I didn't check the time, so I hope that's not too bad for the time.
We've got time. I think for these three presentations, we'll run them one after another and then have questions on them at the end if that's all right. Please think of your questions for Richard. Next up is Stephen McEachran, who's Director of the UK Data Service and the Social Survey in Europe, and is also very privileged there.
Yeah, excellent. So I'm going to talk a little bit about, yes, the work package that we did. This was actually done while I arrived in the UK in August last year. This is work that I did while I was at the Australian Data Archive at the Australian National University. And as I say, continues on, in various ways. So it's sort of a thing that's there. Okay, it was in collaboration with the what was previously called the NSD, the Norwegian Social Science Data Archive, or part of SICT, which is the National Research and Education Service provider. And now they merged a couple of years back. Okay, so this particular work package was really focused on trying to think about what happens when you try to put data that's intended to be together, when you actually put it together. So you talked about RMAP, you know, as a case there. Like, this is a project, a series of projects that say we already know that we want to put the data together. We already know that you know, we've designed it in such a way that it should fit together. What happens when you actually try to do it, and when you try to do it in an automated way? Okay, that's the intent. We know what we want to do. We just want to be able to execute it. And what are the things that get in the way of that? And that was essentially what it was about. So I was really looking at the administrative and data and metadata management procedures, technical environments. What are the implications of actually trying to automate this in ways that allow you to do that data integration at scale? These projects, as I say, and we're using sort of 2 data sources that I've been involved in, but they run every year. There's about 40 to 50 countries involved. 1,000 people at a minimum get surveyed each year, and you're just doing a practice over and over again. They're fielded in. I talked about languages. They're fielded in different languages. So that, you know, the different countries, there is a centralised instrument that's developed in English. Try getting 3 countries who all speak English to talk, you know, to agree on what a term means, and then trying to translate into another language is a whole lot of fun as well. So you know, there are mechanisms for translating languages, you know, that you could be thinking about there. It's not simple, but there are some standard practices that are there, and then bringing that into the data management as well. Yeah, so that and these sorts of groups do work quite heavily in that space. That's not going to be the focus of what I'm going to talk to here, but as I say, it is an important part of the process itself. I was working with the Norwegian archive, whose archive starts in Norwegian. How do you work with that? Okay, so how do we use standards and technologies to sort of to see, you know, how we can manage that process? How do we make them interoperable and reusable? What doesn't work was really the intent here. Can we define the process and then see how well we can implement that process in the 2 countries that were involved, and set out some suggestions for the future of development of cross-national collections into the future. Okay, so the thinking here is, say, we're looking at data harmonisation. You know, we have the data and we want to be able to put it together. You can do this, you know, by design, or you can do it, you know, in practical purposes by what you've got after the fact. These were actually the projects we were working on were actually ex-ante designs, so intended right from the start to be integrated at the point of design. So similar procedures, similar methodologies, and so forth. It's quite common in the social sciences to be doing this after the fact, though. You know, we have surveys run in multiple countries. It turns out we want to, you know, compare between countries, but we didn't intend that in advance. So that's a related problem. We started with a simple problem: is what happens if, you know, we already know that we want to do that. And you can do it in, you know, in increasingly precise ways. So there's different ways of designing it. You can design the instruments in advance, or you can, after the fact, ensure that they are lining up on a conceptual basis, which Simon was referring to as well. There are standards that have been developed for this. There is quite a crossover into the official statistics community as well. So there's the Statistical Data and Metadata Exchange is the standard that's used by the official statistics community, the World Bank, you know, then some of the international economic organisations. It was originally designed for actually managing banking information. You know, high-level exchange. So it has, you know, a lot of investment over a long period of time at a very high level. UN and a lot of the international bodies all, you know, use it as well. At a lower level, it's designed for aggregate information. At a lower level, the Data Documentation Initiative uses a similar structure, has been around since the mid-90s, but the foundations of it actually go back to the 60s as well, around data exchange. Essentially encoding code books and making them machine actionable was the origins of it as well. So there's a framework that sort of exists there, and it kind of lays out, in, you know, essentially in practical terms, what are the things we're trying to do and what are we harmonising. We can start with concepts and conceptual variables. So this is an illustration of marital status. Now, you've got to think about what that means in your own context and situation. But it says, well, there's a concept I'm interested in. In the social sciences, it tends to be a relatively abstract concept. What do we mean to be married? What does the notion of marriage actually mean in the context you're dealing with? Agreeing on a representation of that. So what are when you ask the survey, what are the categories you're going to include? And then the actual implementation of that. We would tend to talk now about more specifically about instance variables. In that survey, in that context, what was the question was asked? What was the codes that we used, and how were they interpreted, recoded? So what happens when you've got someone in a civil marriage, or it might be a non-traditional marriage, or different sorts of arrangements? How do you deal with those? The actuality of it. So a hierarchy there that we're trying to think about, and that becomes kind of useful for bringing those things together. But from data management point of view, actually becomes a bit quite more complex. But now you've got to go back from the instance back to that conceptual level, and you've got to what are the compromises you have to make along the way? And this is the reproducibility problem that was being alluded to earlier. So we can see that kind of represented in a lot of the content that we have. We have variables. We have their representations in different forms. It might be in text. Do you use open text? Do you use numbers? Or do you use categories? Do we agree that male and female are the same? Do we agree? Do we use M and F? Do we use 1 and 2? Some of these things are relatively simple things, but if we're trying to automate these, we've got to make decisions about them. Then there's actually properties of the representations themselves. Simple version of that, and these things might impact on the processes that you use. Richard touched on units of measurement. What's a measure of a unit of well-being is a good example, or a unit, a unit of there are scientific measures that are there. We have units of measure as well, but they become somewhat more complex. What are the text properties, and then how are they encoded? And it turns out encoding is one of the more painful parts of this. Simplest version of that, someone uses a Mac, someone uses Windows. Someone moves from the actual encoding that occurs in the data file itself changes slightly. All the levels up we're having to think about here if we're trying to automate the systems that we're dealing with. So what we did is we took essentially a case study on the European Social Survey, and then implementation against a related program, the International Social Survey Program. As I said, both of these are cross-national surveys. There has been a tradition of doing this manual data harmonisation. We use that as the starting point here and laid out essentially a workflow for that and said, could we instantiate that workflow, or what are the processes we would need to actually put in place? And essentially, this was reviewing a lot of the extant literature around how you go about doing this, and there is 50 years of knowledge about how to do this. But what happens when we actually try to automate some of what goes on here? Working our way down essentially that framework model from concept to specific instance and back up again. We worked our way through the processes themselves and said, well, what are you trying to do in this particular step, and what was the result? I'm not going to go through each of these in turn. I'm just going to quickly give a sense of what the end result was here. There's a summary here, and the slides that will be available. There is also a more detailed report laying out the different stages, a bit similar to Richard's work there, that we can touch on at the end. So essentially, the framework laid out the different processes there. What did we find that worked effectively? A quick highlight. In fact, I will quickly say one of the challenges we had right from the start, and turned about one of the least successful parts, is just getting the data. How do you go about actually going and getting it in a machine automatable way? Now, I could go and download the data. That was possible. Could I go and point to a website that had the data? Yep, that was accessible. Could I get my machine to talk to the other machine to get the data and bring it back again? No, that was a little bit more painful. The other end of the process itself, the registry that was there, was designed for a human to log into the system that's there. Now, we could change that. We could set up our APIs. But here's right from the start, a real pain in the neck for what you might have to do to automate those systems. I've now got to go and redesign my technical systems to understand who it's talking to. Not hard, but it's a blocker right from the start. And this is the point of the workflow, is to be thinking about what are the things we have to make our way through and what's getting in the way and how do we progressively pull those things out of the way, feeding into essentially what, the thinking around the C. diff, that Simon mentioned. What are those factors that might impact upon interoperability? Access rights were the starting point that's there. So this is a summary essentially of the different things that we went through along the way. I would say I'm going to sort of pull through to the end. It's possible to put a lot of these, things in place, but to summarise the process itself, I say, different things work in varying level with varying levels of success. So it kind of works. The human can do it, but you had to do quite a lot of manipulation to get the machine to do it. So where would we, spend our times and our efforts? Part of the thinking here is, well, what's the bit, if you're trying to get to the next step, maybe, where do we invest to ensure that we can move along to the next stage along the way? So importing data was a pain. Establishing the target variables, the endpoints that says this is the agreed definitions, the agreed formats that we're going to use were important. The harmonisation itself was relatively straightforward. There was existing code or code that using existing systems that we could use, write and adopt. Documenting was somewhat of a pain because actually how do you generate automated documentation? In the particular case we're using, these studies have about 300 columns of data across 40 countries they're trying to do, and they're trying to do it every year. We deal with studies often that might have several thousand columns of data to be dealing with. How do you generate that? That is not something that a human wants to be doing over and over again. And then there were some that we couldn't get to at all, and I was sort of touching on the units of measurement and the encoding. Where we did have some sticking points was actually in the data type harmonisation as well. As it was very much of encoding of missing values. If you use two different types of software, how have you dealt with missing values? How have you encoded those values in the software that you're using? Different packages will deal with it in different ways. These are the practical things that start to become a challenge. We didn't get the chance to actually be dealing with that because if you look through where we were getting to here, we were documenting as we went, but actually to deal with the harmonisation on the data types was problematic. So we produced a set of recommendations towards the end about how we could go about doing that. Next time around, we start coming into this, and now we look at the engagement of, well, how might you apply that in other related studies or related circumstances as well. And that's kind of the framing that's there.
Thanks, Steve. Steve will hand over to Shiley. While that's happening, Steve spoke in language of social surveys. If you think about that workflow exists in many areas of science where you need to combine data from those different sources. So the learning from that, one of the wonderful things about WorldFAIR and that petal diagram is how much each work package, each sub-project learned from the others. And there's something that we really put a lot of effort into making sure it wasn't a set of silo work packages. They really spoke to each other an awful lot within those coloured clusters, but across those as well. Next speaker, Shadi Gandhi, who works now at ITU Linz. She's an ISC fellow, and she's been leading Codata's early career program as well until just recently.
Thank you so much for the introduction, Simon. So hello everyone, and today I'm going to talk about this project which has been recently shortlisted in top 10 ISC's grants, what they are going to look for funding, and we'll see how it goes in the coming months. So our project talks about citizen-driven living labs for urban heat islands. This is going to be a women-led transdisciplinary approach, and in a minute I will talk about how it really is going to be transdisciplinary. So what we really want to address from via this project is to look at how urban heat islands have been a big problem in most of the countries, and especially in the Asian countries, because they have more time with more daylight or more sun. What is also very alarming is that these numbers affect like trillions of people across Asia. And when we look at how do we really address these problems, the heat action plans which come up at city level many a times forget to take people in the loop. They forget to include people from various categories and sections of the society. And that's where non-traditional way of data collection, and not just going by the surveys from the government officials or from very, very traditional methods, is approach what we want to take. And also, when everyone is talking about technology, we would like to leverage geo AI technologies to embed these data sets together and come up with a foolproof solution plan which can be useful in policy making. Over here, as I talk about this, there is ample of data sets which are going to be incorporated, and these data sets could be from various sources, and interoperability is going to be a great, great challenge which we want to overcome by using the CIDIF framework. So over here, what we are trying to achieve with our project is to blur the boundaries between disciplines and talk about transdisciplinary approach, where we take citizen, stakeholder, and society into the loop of solution development. This project intersects not only climate change as a SDG goal, but it intersects many other SDG goals, especially where we talk about empowering the women from slum areas to become data collectors for us, training them not only by in basic skills, but also very technical skills of how to measure heat on ground using sensors and various kinds of sensors. And that's extremely important. Health and well-being is also very well addressed because the heat causes a lot of health discomfort, and we would like to see what kind of building materials could be used to reduce the impact of heat on human body. So, and this project is again a partnership with 5 organizations, and that's where we foster the global knowledge and we bring it together on ground for 3 Asian countries, which is based in India, Bangladesh, and Thailand. So the capabilities of the consortium is very, very strong. This consortium is led by the Mahila Housing Trust, which is women-led organization, which works for the society and by the society, completely driven by women from the slums who are being educated to take certain kind of role in scientific projects. It's transdisciplinary, which I spoke about, and the partners have the capabilities to translate the information from various domains into problem-solving approach to address the problems on the ground. And definitely, we have a very, very great scientific network, and with ISC being on the board, it has been enhanced even further. What we really like about this project is that it also talks to the policy actors, and the stakeholders in this project is not only the organizations which are working with us, but also the local government organizations which have come forward and given their support in saying that the outputs of this project would be translated into actions and policies for the future summer months. So we are going to highly encourage open science and use good computer infrastructure to make sure that this project is highlighted and also becomes a test bed for other cities to test how to incorporate science in policy making and make sure that citizens are taken in the loop. And moving forward, briefly, I would like to say what the approach is taken by this organization in India is that they provide urban poor with technical knowledge, equip them with available technologies, and you can see some pictures over there, which is from the pilot they have been doing in Surat for collecting data. So one is they train these females to take a lot of ground measurements, not only based on survey forms which are physical, but everything what they are trying to approach is more digital. So the survey forms are also digitized in mobile phones, they have also trained them how to take location information and be precise about that, so that everything what we are trying to do should be spatially relevant, because that's also very important when you talk about heat action plans or which are the areas which needs attention at this moment. And then a couple of sensors which have also been used by the community. And you would also see, like, it's just not women, but women from all age group, and also few men are involved to collaboratively, raise their voice and say, this is our problems, or we also want to be part of, the community which takes decisions. And while capacity building is the key role, over here we also implement resilient action plans, advocacy, and going back to the government organizations and saying that this is what would matter. Say, today this particular area is getting heated a lot, and planting few trees over there would really matter to us and our health. And that is where we close the loop and make it very transdisciplinary, where it starts from data, talks about science, apply algorithms, and then take the results back to the decision-making organizations to make sure that everything what we are talking about over here is implemented in real life. And yes, this is how our mission really looks forward to make sure that scientific and systems approach is taken, where we use a lot of technology to make sure that whatever we are talking on grounds is also being translated and proved with scientific methods. And we wish to have living labs which incorporate of people from the community to become real, drivers for taking these changes forward. And inclusive heat action plans is what we are expecting to be the final outcome of this mission science project, where we would be very happy to collaborate, and we've got full endorsement from all the 3 municipal corporations to cooperate with us and implement the outcomes of our result on the ground. So looking at how sustainable solutions approach, what we would be taking in this project is we would look at holistic and multi-stakeholder approach, where stakeholders from different divisions of the society and different hierarchies of the administration will come together and work with the women who are going to lead this project, on-ground organizations and civil bodies. Everyone would be involved in data collection process in different levels, which I'll talk in the next slide. And then scientific communities will come with their own expertise in different domains like climate change, social science, talking about how people's perception is important, and a lot of satellite data sets would be used to identify heat pockets in the cities. And finally, everything what is being consolidated together from these data sources and the knowledge which is being gained would be translated to the policymakers in an understandable format, which is again a very big thing, because if we throw like thousands and millions of data sets on someone who wouldn't really understand it, doesn't make sense. And at the end, after everything is for citizens. So we would like to also build a platform where citizens can see the outputs and also understand more about how urban heat islands can impact their health and take preventive measures. So this is how the whole sustainable holistic approach, what we are going to take for this solution. And what are the disciplines over here? Because I really want to talk about climate resilience is not a topic which can be addressed by single discipline. It is a very transdisciplinary approach, and we need to make sure that all these disciplines talk to each other and they understand not only the language, but also the data from various disciplines. And that is extremely important and challenging at the same time. So here for this project, of course, we would be working very closely with urban planners and social scientists, government organizations, because they are the ones who can bring in change, computer science, machine learning, and AI experts to make sure that our processes and data process faster than expected. And then we have a lot of special data science and information models what we want to use, because when we are talking about cities, when we are talking about spaces, we also want to make sure that we know things exactly where what is there. And that's the key of this project also. And data stewardship is going to be a very key component of this project, because we want to make sure that we translate the knowledge of data sharing to the lead organizations so that in future they can take these steps by themselves and they are not always dependent on other organizations. And data policy is, of course, the next key point, where we want to make sure that everything what is being done has a clear data policy and it translates into ground solutions. Very quickly, we are going to take all the scientific, qualitative, quantitative methods into play, computational data analysis technologies, and a lot of data stewardship would be part of this project. We would also adapt systems approach to make sure that we have everything in place scientifically, and vulnerable communities is a very big component, which would be completely co-designing this project to make sure that it is more inclusive and everyone's voice is heard. And towards the end, we should have the living labs which stay and they are sustainable for the future. Now, coming back to the data sets and what we've identified as a full horizon of data sets which would work over here, and most of the data sets are also multimodal data sets, because they are not only in text or image format, but they have different formats. So here we start with satellite images, which are definitely sentinel images, MODIS images, and various satellites which give you thermal information. And then we take social media information. Social media information has also been a very strong tool to identify disasters and climate change opinions from users. Here we could do a lot of sentiment and topic analysis to identify which are the regions of concern. And this is again a very, very good platform to test if the citizens have a view or they want to, give back without their name being mentioned, because that's a platform where people share their opinions without being biased, right? And then geospatial data. So there's a lot of geospatial data which is being collected by the organization on the ground, is basically using sensors information, going on the ground, taking measurements with various kinds of sensors. And this image is also from one of their ongoing project where they clicked the picture with thermal camera, and you can see how the car is more warmer than the trees around it, right? So different aspects of collecting the data in different formats. This is an image from one of the sensors which works and is mounted on the car to take the air temperature. And then surveys and interviews are always a big part, where people work together and take surveys using mobile applications. And citizen science is where we want the community to sit together, work on maps, and talk about what really matters to them in their location. So we are pretty much ready and waiting for the funding for this project. We have our work packages defined, and all the partners are eagerly and keenly waiting to kickstart this project. So thank you very much.
Thank you very much, Shanae. We've got about 10 minutes for any questions on those three presentations, or on the whole activity. I hope you can see from each of those presentations that perhaps CoData in the past has sometimes stood on the boundaries, saying this would be good. It would be good if organizations did this with their data, making policy recommendations, etc. But I think in recent years we've realized that we can work a lot better by getting directly involved with particular subject areas, with particular projects. And I think you saw with Shiley's presentation as well, the purpose of that project is to make change on the ground, and that requires the science and the evidence and the stakeholder involvement, but it also requires the data. And for those data to be high quality, and for us to be able to present those data, to integrate those data in such a way that we can do the science, that we can do the analysis, that we can have those discussions with the communities involved. So there's there's a chain of participation and involvement which is necessary, and I think CoData feels that we can increasingly work by being involved in the science, not to create individual solutions, but then to step back and to make solutions that are generalizable. So it's a slight change in tactic or approach that I think CoData's trying to do, and that's what we've tried to illustrate in the presentations today. Any questions or responses? Yeah.
Thank you all for your speakers. My name is Khaled Rai, Dr. Khaled Rai. I'm asking about the working flow. Is gonna facing missing value since we passing that data?
So
The-
I'm not sure that I fully understood
The work,
the workflow.
yeah.
Hmm.
So we can sometimes facing problem for the value of that data.
The value in what sense?
Data. Data following flow. It's mean like if you get the data, is something interrupting, cutting air or hackers or something like that.
Right.
Would that's be sometimes not be correct or got be changed for the same kind of added or deleted from that
Right.
that database.
Okay. Faulty data. Yes, yes. So, I mean, all the organizations and the projects that we work with are, of course, concerned with maintaining their processes and the integrity of their data. And one of the things that we do with organizations with are recommendations about how to maintain data integrity. Organizations like Steve's have this baked into their daily work to maintain the data integrity from the data that they received and then how they present it and supply it with users. I'm not going to say it's not a problem, but it's it's something that we it's part of the problem space that we work with all the time.
In that space, that's where the things like the validation suites that I talked about are important, because when you're automating things and doing things at scale, finding the deficiency in data is much more difficult. The validators, they don't fix the data. What they do is they help you find the places where there are problems, and so then there's going to be human intervention at those particular places. And so nearly always you have to have a human intervention to work out what to do. But the hard bit often with large amounts of data is working out where the problem is. And that's where the validation suites come in handy. I gave you examples from chemistry, but where there are features that are anomalous, they can be identified, flagged, and then the researcher can work out what the solution will be in that particular case.
My colleague from Turkey, and then Diana. Yeah, I think my question involves Steve's point. Yeah. When we are importing data, actually, we saw the data in the database correctly, no problem. But when it is imported, we get gibberish. We don't understand and especially this is a problem with the geographical names and other things. And we need a specialist, in order to just sort out the names. Actually, is there any way that your flowchart actually starts with the importing, but the importing was a big problem, to begin with?
Yeah, I mean, oddly, this is a version of Richard's validation point. The point this is here, which is, yes, as I say, it's this mix of human and machine. That tends to be the challenge there. As you say, you're importing the content now. As I say, and you've got to kind of be diagnosing what was the source of the error. Was it you're getting gibberish? Is it simply the formats are incompatible, or is it those special characters that happen to be in the place names along the way? But those validation suites are trying partly to say this is valid or actually this is invalid. There's something to be done here. That was essentially the purpose of what I was doing. Was we didn't really have a at what points are we having to do the automated validation along the way? Now we do this internally in our archive, but it's a very manual process. So how do you progress? Say it's not a scalable process. How do we progressively move towards taking those they are generalizable. There are some certain types of problems that we know are not social science problems. I said that, I use the missing data as an example there because it's like that's a problem that exists across the sciences, but we need a solution for it. So what's that solution going to be? Or is it something specific to the domain? Is it is it a geospatial issue? Is it a language issue? Being able to do those diagnoses becomes part of the equation. But it's looking for procedures that are relevant across the domains. Those are probably the scalable parts. Then the specifics of the domain knowledge that you need there. I mean, you talk about being a physician. What is those medical terms that don't make sense? Would be an example there. Mm. Yeah.
So that idea of being able to search across a whole load of federated set of data services or repositories or databases globally. In genomics, they've been doing that to a degree with the BLAST search, with the BLAST. But, so many other research areas would benefit from that degree of data integration or collection in something like GBIF, or data federation across a whole load of national databases. And it seems that this mission of science to make that data, those data resources available at scale globally has somehow been forgotten, relatively speaking. That was part of a positivist, in the history of science, a positivistic idea that this was what science was for, that we had to collect those data at global scale. And we have examples of that. And then periodically, these ideas reemerge. So with the creation of GBIF in the late 90s, etc. But it's patchy. And many other research areas just do not have this. And there are something that we encounter all the time and that we reported on in WorldFAIR is how many research disciplines spend a lot of time. There are services which extract data from articles and put them in a database. Strikes me that this is exactly the wrong way around. The data should go into a data service so that it's there and we know it's there, and the articles can be published as well. But we shouldn't be doing this task of extracting data from articles and trying to aggregate it, which is more expensive and partial. Any more questions? Oh, Diana, you had a question.
No. Thank you very much to the three of you. Can you hear me? Yes. Okay.
Yeah.
So maybe this is for Shaili, but maybe to all of you. How do you measure the success of these projects? I mean, beyond the gathering of the data and beyond the fact of empowering all these women. So how can you measure the true impact of all these projects, or all the case studies that you were mentioning before? Because when the funding is over, what's the preservation and what's the future of all these projects? We don't want them to be ephemeral. So how can we measure that this research will really reach policymakers?
So for specifically, I'll talk about the project I spoke about. The real measurement of success would definitely be the trainings, because you are actually training a community which is committed, and they are not doing it for their daily living, but they are doing it for uplifting their lifestyles. And the second is definitely if even a partial part of the whole outcome or learning is implemented as a policy, it just goes on as an impact to the society. So translating the information into policies is something what we expect, and have got as outputs in the past working with Mahila Housing Trust. So we have seen those kind of success measures where we see that we've trained the community and we've seen how they know how to take their voice ahead in the government and get reasonable implementations done. Yeah.
I'll just add to that point this is one of the shortlisted projects as part of the ISC's Science Missions program. So the principle of that program, the hypothesis or the wager that they have made is that by endorsing that with ISC, by having a matchmaking process with funders, by having that as a program, we can raise the transdisciplinary methodology to a high level. We can get policymakers more interested in that, and hopefully to get global policymakers interested in the outcomes of the projects. Now, that's a hypothesis at the moment. That's the principle of the program. That's what it aims to achieve, and we'll see whether that will happen. But I think we have to back that horse at the moment and support it and do our best to make it a success. As members and organisations established by ISC, we want to support that and try and sort of back that bravery of creating that program.
Yes, this is for the Professor Richard, and because we generate a large number of the bigger molecules, like from the proteomics, metabolomics, genomics, can we key them into this? The keying thing, we can adapt them into the keying.
So you're asking whether big stuff can be
big
put
stuff,
in it.
yeah.
Can we deal with that in the with the International Chemical Identifier?
Yeah.
Not yet, but we're working on it.
Okay.
Okay. So we are building the INCHI program to be able to cope with different classes of molecules, and the macromolecules is one of the areas where we are looking to do that work. But there are also related tools that we might be able to interface with or use the technology from in order to make that happen. Yeah. So not yet, but hopefully soon.
Okay, great. Thank you.
We're, I think, 4 or 5 minutes over time. Although that clock says we're on time, but I think mine says 5. So I think we should wrap up if there are no more questions. I will close with this. So, I presented at the beginning that narrative. We have WorldFAIR Plus now as an initiative combining a set of already funded projects, but also, and I don't think I stress this enough, existing partnerships as well, with IUPAC, with One Geochemistry, which is carrying on, etc. So it's a vision of these federated projects and partnerships. So our question for you is, do you have a potential project, initiative case study, where we can work with you, where we can make the data fair, where we can demonstrate the benefits of combining those data for those science objectives, and we can work with you on CDIF implementation, implement, test, refine, extend? Please let us know. There's more information here, and here about WorldFAIR Plus. WorldFAIR Plus has been endorsed as an ISC project, an ISC initiative. There's a lot of material on the ISC website of that, so we're doing it with the blessing of ISC and with some collaboration and support from them. If you have ideas of a project or a partnership, please get in touch. We'll speak to the scientists, speak to the data experts, we'll develop a plan and a lightweight MOU or a letter of agreement, and we hope to expand the program even further on that sort of basis. Thank you very much. Please get in touch.
Fantastic thing, a lot of there is a good opportunity, especially.
You should get in touch. It sounded like your project is one that we could really help with.
Yeah, that's what
I was actually in Sri Lanka in December. So
is it okay?
Yeah. I was
holiday
speaking at the SLAS. The
last December, is that?
Yes,
I miss actually. I was invited.
Well, we would have met then.
Yeah, exactly. Actually, I was invited as a
the guest, like I'm a chairman of the National Science Foundation.